Assalamu alaikum warahmatullahi wabarakatuhu. So in the today's video we will look about the we'll learn about the per unit system of measurement. Per unit system of measurement. So the per unit system actually converts all the voltage levels and all the parameters of the transformer and the power system to within a certain limit, so that we can easily understand about our big power system. So this will obviously simplify our analysis without transforming the voltages from to the primary side or to the secondary side. So in this per unit system, the voltages, currents, power impedances, and other electrical quantities are not measured in their usual SI units, just like volts, amperes, watts, ohms, etc. Instead, each electrical quantity is then measured as a decimal fraction of the sum base level. So in this system, any quantity can be written as quantity we want to measure, can be written as quantity in per unit, that will be equal to actual value divided by the base value of quantity. So where actual value is a value in volts, amperes, ohms, etc. So it is normally sometimes customary to select two base quantities to define a given per unit system. So the mostly used base quantities are the voltage and power, or sometimes apparent power. So once these base quantities have been selected, all other base values are related to them by usual electrical laws. So in a single phase systems, these relationships are just like for the P base, Q base, or S base. They all can be written as V base into I base. Similarly, R base, uh, X base, or Z base can be written as V base over I base. So then Y base admittance will be obviously I base over V base, and Z base is equal to V base whole square by S base. So once the base values of S or P and V have been selected, all other values can be calculated by using these relations. So a base apparent power and voltage are selected at a specific point in the system. So because we know that the transformer has no effect on the base apparent power of the system, since the apparent power into the transformer equals the apparent power out of the transformer. On the other hand, voltage changes when it goes through a transformer. So the value of V base changes at every transformer. So if we are working on a power system and if we have more than one transformers, so the voltage base voltage will be different for each transformer, because it totally depends upon the turns ratio of the transformer. So let's look at this simple example to understand this concept. So it says that a simple power system is shown in figure here. In this figure, if we look here, we have the generator and one step up transformer because it is 1:10, and this is the line impedance, and then we have the step down transformer, and then we have this load. So the system contains a 480 volt generator connected to an ideal 1:10 step up transformer, a transmission line, an ideal 20:1 step down transformer, and a load. The impedance of the transmission line is 20 plus J60 ohm, and the impedance of the load is 10 angle 30 degree ohm. The base values for this system are chosen to be 480 volt and 10 kVA at the generator. So now find the base voltage, current, impedance, and apparent power at every point in the power system. So it means that we have to find the base values here, here, and on this side. So how we can find out? That's quite easy. Let's solve it. So the first part, once again, let's look at here. It says that find the base voltage, current, impedance, and apparent power at every point in the power system. So first of all, we need to calculate I base 1. I base 1 will be S base divided by V base 1. So that will be at the generator side, and we have given this 10 kVA, 10,000 VA divided by 480 volt, and this comes out to be 20.83 ampere. Then we have Z base 1, and Z base 1 will be V base 1 divided by I base 1. So V base 1 is already given, which is 480 volt, and we have calculated this I base 1, which is 20.83 ampere. So that quantity will be approximately equal to 23.04 ohms. Now we know that the turns ratio of the transformer T1, say this is T1 and say T2, so the turns ratio of the transformer T1 is 1:10. So here A will be NP over NS, which is 1/10. So that will be 0.1. So the V base simply 2 will be simply V base 1 by A. So that would be 480 volt divided by 0.1. So that will be 4800 volt. Now S base 2, that will be on this side, this portion, S base 2. So As we know that the apparent power stays the same, so that will be same 10 kVA, and I base 2 will be then 10 kVA or 10,000 VA divided by 4800 volt, because we have the V base 2. So that will be approximately equal to 2.083 ampere. Similarly, Z base 2 will be equal to V base 2 divided by I base 2. So that will be V base 2 is, obviously we have already 4800 volt divided by I base 2 is 2.083 ampere, and that's approximately equal to 2304 ohms. Similarly, now we will move to the next part, that is the load part, and here the transformation ratio A, which is NP over NS, is 20:1, so it is 20/1, which will be 20. So the V base 3 will be equal to V base 2 divided by A. So V base 2 is, we know it is 4800 and divided by 20 volt. So that will be simply 240 volt. Now similarly we can find out the S base 3. Again, remember that the apparent power stays constant, 10 kVA, and then we can find out the I base 3, that will be equal to 10 kVA divided by V base 2, we have calculated it to be 240 volt. So that will be approximately equal to 41.76 ampere. Then we have Z base 3, which is equal to 240 volt divided by 41.76 ampere. So that will be approximately equal to 5.76 ohm. Now let's look at the second part. So convert this system to its per unit equivalent circuit. So now we have to convert all these values to the per unit system. So B part, in which we need to convert every unit into the per unit system. So starting from the generator, so V generator per unit will be simply 480 volt with 0° angle, because we are taking it as a reference, divided by 480 volt. So that will be obviously equal to 1.0 with angle 0° PU per unit value. Similarly, Z line per unit will be simply, we have given this 20 plus J 60 ohm divided by, so the line base value resistance Z is 2304 ohms. So that will be approximately equal to 0.0087 plus J 0.0260 ohms. So similarly, we can find the Z load per unit. So Z load is per unit is given as, so remember, actual value divided by the base value. So actual value that is already given is 10 angle 30 degree ohm divided by 5.76 ohm. So always remember that per unit has no unit, as we have discussed earlier. So that will be equal to 1.736 with the angle of 30 degree PU, or that will be 1.503 plus J 0.868 PU. So this was the second part. Now let's look at the third part. It says that find the power supplied to the load in this system. So we need to find the power that's been supplied to the load in this system. So C part, it says the power. Now I per unit is V per unit divided by the uh, Z total per unit. So total per unit means that total per unit means Z line per unit plus Z load per unit. Now that will be quite easy to find. So V per unit is we know that given as 1 with angle 0 degree, and this one Z total per unit is the sum of Z load per unit and Z line per unit. So if you put these values here, so we will get this number 0.569 with the angle of minus 30.6 per unit. So and then we need to calculate the power that's been supplied to the load in per unit. So that will be I square, sorry, I per unit square times R per unit. So I we have calculated here, so 0.569 whole square into R per unit is 1.503. So that will be equal to 0.487. And the actual power, if you want to know the actual power that's been supplied to the load, so that will be simply, we can transform this per unit value into the actual value, that will be P load per unit into S base. So that will be 0.487 into 10 kVA, 10,000 VA. So that will be simply 4870 watt. Now let's look at the next part of this question, and it says that find the power lost in the transmission line. So we need to find the power loss in the transmission line. So that is straightforward. D part, it says that we need to find the power line in per unit. So that will be I per unit square R line per unit. So that will be equal to 0.569 square times the 0.0087. So that comes out to be 0.00282 per unit. And the actual power, line power, will be line losses, we can say in other words. So P line will be then P line per unit times S base. So that will be 0.00282 into 10,000 VA. So that will be equal to 28.2 watt. So here we have seen that we don't have to transform the impedances towards the primary side or secondary side. So still we can analyze our system with the transformer by using these per unit values very easily and accurately. Hopefully you have understood the per unit system. I will urge, if you would like to solve some more problems from the exercise of this book. So if you if you want to ask any questions, feel free to ask me. Stay blessed. Assalamu alaikum wa rahmatullahi wa barakatuh.